They are the best gardeners of my generation. I realized at a certain point. The best gardeners of my generation are not hybridizing roses, are not, working with orchids. They're working with this incredibly valuable, incredibly interesting plant called cannabis.
If this turns into anything good, though, look at it. I mean, this is how thick the stalk is when it's just gone to bloom.
It's got a beautiful shape.
It is nice.
I mean, think about it. This thing's a weed.
Yeah.
It's a weed. It's a weed that's worth, in the open market, like, $6,000, $7,000 a pound. Pretty good for a weed, huh?
But cannabis only fetches that price because of that one particular molecule it makes that gets people high. Its name is THC, and it was discovered back in 1964 in a lab in Jerusalem by chemist Raphael Mechoulam.
Cannabis had not been well investigated, which was strange. After all, it was being used illegally or illegally by millions of people, and yet we didn't know that much about it. So I thought it's a good idea to look at it again from a modern point of view.
In the lab, Mechoulam and his colleagues broke cannabis down and zeroed in on the chemical components that might be causing its effects.
We isolated about 10 compounds. Surprisingly, out of the 10 compounds we isolated, only one, which now is known as delta-9 tetrahydrocannabinol, in short THC, only one causes the well-known high. We tested it in humans, many of my friends, and we saw that the compound is effective as we expected it to be.
The identification of THC answered one question, but raised another. Just what did it do to the brain?
I had always assumed that people knew how marijuana worked. It surprised me, actually, when I began looking in the research literature that it was really clear that no one really knew how it worked.
In 1988, Lynn Howlett found the answer. She discovered that deep inside the brain, THC molecules activate a previously unknown network of specialized chemical receptors.
So that was proof that there is a receptor protein in the brain that can bind to the THC like a key in a lock.
It was very exciting because what that meant to us was we had a tool that could be used for studying, and other researchers could use it as well. And people could study where the receptor was in the brain.
Howlett and other scientists found the receptors in the hippocampus, which forms memories, the cerebellum, which controls movement, and the frontal cortex, where we think.
Here were these receptors that this chemical produced by a plant out in the world just so happened to have the precise combination to unlock. What an extraordinary thing that is. Is that why that receptor network existed, so that people could get high?
We don't have those receptors just so that people can get high smoking pot. Receptors are developed in neurons so that they can communicate with a chemical that the body makes.
So that was the logic behind going in and trying to extract a compound in the brain that would act just like marijuana did.
And in 1992, proof came that the brain does make a compound very much like THC. It was discovered by none other than Raphael Mechoulam, who named it anandamide.
We call it the brain's own marijuana because the compound that is made by the brain, anandamide, shares all the properties in terms of at the receptor level and cellular level that THC has.
It turns out that when anandamide is released in the brain, like marijuana, it affects such basic things as appetite, pain, and memory. And it plays a critical role in a sometimes underappreciated mental function, forgetting.
When I first heard that, it didn't seem adaptive to me to have a drug for forgetting. Memory, we understand, has great survival utility. You learn that that's a poisonous mushroom or that's a dangerous animal, and you stay away and you remember that. But why would forgetting be adaptive? And I asked Mechoulam this question, and he said, well, tell me, do you really want to remember all the faces you saw on the subway this morning? Forgetting well is almost as important as remembering well. Forgetting is about editing. It's about taking the flood, the ocean of sense information coming at you and forgetting everything but what's important. So life is not just about accumulating new memories. Memory can cripple us too. You have soldiers returning from war zones that are traumatized by experiences that, in effect, they can't unlearn. So if you could help them unlearn that, essentially a productive kind of forgetting, either with a drug or some other kind of regime, that would be incredibly useful.
And that's exactly what Aaron Lichtman is trying to do. He's studying how mice remember and forget. First, he trains them to find an underwater platform.
The mice are natural swimmers, but they're looking for a way out. They swim all around the perimeter of the tank. They're swimming, swimming, swimming. Sometimes they bump into the platform by mistake and they climb onto it. Other times they never find it. So then at this point, he's been at it for a while, and the experimenter has to gently guide them to it or place them on the platform.
Then, Lichtman takes the platform away. A normal mouse quickly realizes the platform is gone. But a mouse whose anandamide receptors have been blocked is unable to forget.
They don't learn to give up. They keep on looking for that platform even though it's gone.
Scientists like Lichtman hope that learning how to regulate anandamide may one day lead to treatments for people who are haunted by their memories.
If they can elevate naturally occurring anandamide in humans, we might be able to have whole new therapeutic targets to treat post-traumatic stress syndrome.
By using a plant that has been around for thousands of years, we discovered a new physiological system of immense importance. We wouldn't have been able to get there if we had not looked at the plant.
These plants are constantly undergoing this revision and this re-revision in our cultural imagination, depending on what uses they're playing for us.